Far beneath the sunlit surface of the Pacific Ocean lies a world of crushing pressure and eternal darkness. It is a place so alien, so remote, that for centuries it existed only in the imaginations of explorers and dreamers. The ocean's surface, shimmering and alive with the play of sunlight, gives no hint of the abyss that waits below, a realm where the rules of life and survival are rewritten by the sheer force of nature. This is the Mariana Trench, a place more remote and less explored than the surface of the moon. Out here in the vast emptiness of the Pacific, the horizon stretches endlessly in every direction, and the nearest land is hundreds of kilometers away. The trench itself is hidden, invisible beneath kilometers of restless water, its secrets guarded by the ocean's immense depth. It is the deepest point on our planet, a vast scar in the Earth's crust that plunges to depths of nearly 11,000 meters. Imagine a canyon so deep that it could swallow the world's tallest mountains with room to spare, a chasm carved by the slow, relentless movement of tectonic plates over millions of years. Here the weight of the water above is immense, over 1,000 times the pressure we feel at sea level. Every square inch is pressed upon by a crushing force, a silent, invisible hand that shapes everything in its domain. It is so powerful that it could crush a submarine as easily as we might crush a tin can. The very materials we rely on for strength and safety are tested to their limits here, and only the most carefully engineered vessels can survive the descent. The temperature hovers just above freezing, and sunlight has never once pierced this profound gloom. The water is so cold that it chills to the bone, and the darkness is absolute. A blackness so complete that it is impossible to tell up from down. Imagine a place so deep that if you were to place Mount Everest at its bottom, its peak would still be submerged by over 2 kilometers of water. The scale is almost beyond comprehension, a vertical journey that dwarfs anything found on land. The trench stretches for an astonishing 2,550 kilometers, a colossal crescent-shaped chasm hidden from our view. Its walls are steep and jagged, descending into the unknown, and its floor is a landscape few humans have ever seen. It is a world seemingly hostile to life, where the conditions are among the most extreme found anywhere on Earth. The landscape is barren, rocky and silent, shaped by forces that have been at work for eons. For centuries we look to the stars as our final frontier, yet a realm of equal mystery and wonder has always existed right here beneath the waves. The ocean's depths have inspired legends and fears, but only recently have we begun to truly explore their secrets. This is a journey into that final frontier, a descent into the very heart of our planet's oceans. Each dive is a leap into the unknown, a test of human ingenuity and courage. This abyss is not a barren wasteland, as one might assume. In the darkness, life has found a way to endure, to adapt, and even to flourish. It is a dynamic and surprisingly vibrant ecosystem, home to creatures that have evolved in ways that defy our imagination. Some glow with their own light, others have bodies built to withstand the crushing pressure, and all are uniquely suited to this alien world. They thrive without sunlight, drawing energy from sources we are only just beginning to understand. Around hydrothermal vents, entire communities of life gathers, feeding on chemicals that would be toxic to most surface creatures. The journey down into the trench is a passage through different worlds, each with its own unique inhabitants and rules for survival. From the sunlit shallows to the pitch-black depths, life changes and adapts in extraordinary ways. From the twilight zone, where strange predators hunt with their own living lights, to the floor of the Challenger deep itself, life finds a way. Even here at the very bottom, creatures move and feed, their existence a testament to the power of adaptation. It is a testament to the sheer resilience and adaptability of nature. Every organism here is a survivor, shaped by the relentless challenges of their environment. Our understanding of this deep-sea realm is still in its infancy. Each sample, each image, each discovery adds a new piece to the puzzle, revealing a world more complex and interconnected than we ever imagined. We have sent more people to the moon than to the bottom of the Mariana Trench. The challenges of reaching these depths are immense, requiring technology and bravery on par with space exploration. Every expedition that braves the descent brings back new questions and astonishing discoveries, revealing a complex web of life that has been hidden from us for millennia. Each journey uncovers new species, new behaviors, and new mysteries, reminding us how much we have yet to learn. But our reach now extends even to this most remote of places, and with it comes a responsibility. The choices we make on the surface ripple down to the deepest parts of the ocean, affecting life in ways we are only beginning to understand. The story of the Mariana Trench is not just one of exploration and discovery, it is also a story about our own impact on the planet, an impact that is now being felt in its deepest, most secret corners. Even here in the heart of the abyss, the traces of humanity can be found, reminding us that the final frontier is not just a place to explore, but a world to protect. The Mariana Trench was not created overnight. Its formation is a tale of immense geological forces, a saga that spans over 50 million years. These forces have sculpted the Earth's surface, creating mountain ranges and deep oceanic trenches. The Mariana Trench is one of the most dramatic examples of this geological artistry. It is a story written in rock and water, a slow but powerful dance of the Earth's tectonic plates. These plates are massive slabs of the Earth's lithosphere, constantly moving and interacting in a dynamic process. The trench marks the boundary where two of these colossal plates meet, the ancient dense Pacific plate and the younger, lighter Philippine Sea plate. This boundary is a site of intense geological activity. Here, a process known as subduction takes place. Subduction is a geological process where one tectonic plate moves under another, sinking into the Earth's mantle. The Pacific plate, being heavier, is forced to dive or subduct beneath the Philippine plate, plunging deep into the Earth's mantle. This process is responsible for the creation of the trench. This cosmic collision is what has carved out the deepest chasm on our planet. The trench is a testament to the immense power of geological forces. Several unique factors contribute to the trench's extraordinary depth. Its location and geological history play crucial roles. Unlike many other oceanic trenches, it is located far from any major continent. This isolation has preserved its depth over millions of years. This means it has not been filled in over the millennia by the sediment and silt that rivers wash into the sea. The lack of sedimentation has allowed the trench to maintain its profound depth. Its geological isolation has preserved its profound depth. The trench remains one of the most pristine and untouched places on Earth. Furthermore, a series of faults near the trench allow the descending Pacific plate to bend at an unusually steep angle, plunging downward almost vertically in some places. This steep angle contributes to the trench's dramatic depth. This sharp downward bend helps to create the sheer, deep walls of the abyss, making it a particularly dramatic and deep subduction zone. The trench's walls are some of the steepest and most imposing on the planet. There is another fascinating process at play here, a phenomenon scientists call slab rollback. This process further contributes to the trench's unique structure. As the Pacific plate sinks, it pulls the overriding Philippine plate along with it, stretching and thinning the crust behind the trench. This stretching creates additional space, deepening the trench further. This process has essentially opened up a new basin, the Mariana Trough, and contributes to the overall structure of this complex underwater landscape. The trench and the trough together form a unique geological feature. Water from the ocean seeps down through cracks in the crust, reacting with the rock to form new minerals like serpentine. This mineral formation is a key aspect of the trench's geology. This interaction between water and rock is not just a geological curiosity. It is believed to trigger some of the deepest earthquakes ever recorded, reminding us that this is a geologically active and volatile region. These deep earthquakes are a testament to the immense forces at work. The result of these powerful, slow-moving forces is a feature of staggering proportions. The Mariana Trench is the deepest part of the world's oceans, a place of immense depth and mystery. The Challenger Deep, the trench's deepest point, is a small, slot-shaped valley on the floor of this much larger structure. It is the deepest known point in the Earth's seabed. It is the ultimate expression of this geological drama. The trench floor is a place of extreme conditions, with crushing pressures and near-freezing temperatures. For millions of years, this process has continued in silence and darkness, shaping a world that is utterly alien to our own. The trench is a place of mystery and wonder, a testament to the power of geological forces. Understanding its formation is the first step in appreciating the unique conditions that have given rise to the life that exists there. A world born from the slow, inexorable collision of continents beneath the sea. The Mariana Trench is a place of profound geological significance, a window into the Earth's dynamic processes. For countless generations, the deep ocean was a place of legend, fear, and boundless imagination. Ancient mariners gazed out over endless blue horizons, their minds filled with stories of sea monsters, lost cities, and uncharted worlds lurking beneath the waves. The ocean's true depths were hidden, its secrets protected by darkness and crushing pressure. What lay beneath the waves was a complete mystery. Even the bravest explorers could only guess at what existed in the blackness below, their ships tossed by storms and currents above an unseen abyss. The first real clue to the ocean's greatest secret came in 1875, when the HMS Challenger set sail on a journey that would change science forever. This was no ordinary voyage, it was the world's first true oceanographic expedition. A floating laboratory packed with scientists, sailors, and the most advanced equipment of the era. The Challenger's crew used a simple but ingenious method to probe the unknown. They lowered weighted ropes, sometimes thousands of meters long, into the sea, waiting for the faintest touch that signaled the ocean floor. Each sounding was a test of patience and nerve. As the rope disappeared into the darkness, carrying with it the hopes of discovery. In the vast, stormy waters of the western Pacific, the Challenger's crew made a measurement that stunned the world, a depth of over 8,000 meters. At the time, such a number seemed almost impossible. A chasm deeper than any mountain was tall. Carefully, they recorded their findings in ship logs and marked the spot on their maps. In honor of their vessel, they named this mysterious place the Challenger Deep. A name that would echo through the annals of exploration. For the first time, humanity had peered into the abyss, glimpsing a world that had been hidden since the dawn of time. But the true nature of the trench remained out of reach, its secrets locked away by distance and danger. Decades passed. Technology advanced, but the trench remained untouched. Generations of scientists dreamed of visiting the Challenger Deep, but the journey seemed impossible. The crushing pressure, the freezing darkness, and the sheer remoteness of the site made it one of the last great frontiers on Earth. Then, in 1960, a new chapter began. The bathyscaphe Trieste, a strange balloon-like vessel with a thick steel sphere for its crew, was prepared for a daring descent. Engineers and explorers gathered on the deck, their faces tense with anticipation. Inside the cramped cabin were two men, Swiss oceanographer Jacques Picard and U.S. Navy Lieutenant Don Walsh. They squeezed into the tiny sphere, surrounded by controls, gauges, and the hum of machinery, ready to risk everything for a glimpse of the unknown. As the Trieste began its descent, the world outside their porthole faded from blue to black. For nearly 5 hours they dropped deeper and deeper, the pressure mounting with every meter. The only sounds were the creaks of the hull and the steady breathing of the explorers. Finally, after a journey of nearly 11,000 meters, the Trieste touched down on the silty floor of the Challenger Deep. The cabin shuddered as they landed, and for a moment time seemed to stand still. With trembling hands they switched on their lights, piercing the eternal darkness. What they saw was astonishing. Life where none was expected. A flatfish, perhaps a type of sole or flounder, glided away from the submersible's lights, its pale body a ghostly shape against the mud. In that moment Picard and Walsh proved that life could survive even in the most extreme conditions on Earth. After their brief visit, the Trieste began its long ascent, leaving the trench undisturbed for more than 50 years. The technical challenges of returning were immense, and for decades the Challenger Deep remained a place of legend once more. But human curiosity is relentless. In 2012, filmmaker and explorer James Cameron set out to make history. He spent years designing the Deep-Sea Challenger, a sleek, high-tech submersible built to withstand the crushing pressure of the trench. Cameron's solo descent was a feat of engineering and endurance. He spent hours on the sea floor, capturing the alien landscape in stunning, high-definition, three-dimensional video. The world watched in awe as he revealed a place few had ever imagined. His journey ignited the public's imagination. News outlets broadcast the footage, classrooms buzzed with excitement, and a new generation of explorers dreamed of venturing into the deep. The Challenger Deep became a symbol of the unknown, a call to adventure for scientists, engineers, and dreamers everywhere. It reminded us that our own planet still holds mysteries as profound as any in the cosmos. Since then, exploration has entered a new and thrilling era. Modern submersibles, bristling with sensors and cameras, now probe the trench with unprecedented precision. In 2019, explorer Victor Vescovo piloted the DSV Limiting Factor, a revolutionary submersible capable of repeated dives to the deepest parts of the ocean. For the first time, the Challenger Deep became a place that could be visited again and again. These missions have allowed scientists to systematically map the seafloor, revealing the trench's contours in exquisite detail. They have collected samples of rock, water, and living organisms, each one a treasure trove of information about life at the edge of possibility. This new wave of exploration has confirmed the trench's staggering depth and led to the discovery of bizarre new species. Creatures adapted to survive in a world of darkness and pressure. But these triumphs have come with a sobering realization. On one of the very first dives, the Limiting Factor's cameras captured a plastic bag and candy wrappers lying on the seafloor, an unmistakable sign that even the most remote places on Earth are not beyond humanity's reach. It was a stark, disappointing reminder that our impact extends to the deepest corners of the planet, challenging us to protect the wonders we have only just begun to understand. Imagine descending into the ocean, past the sunlit shallows, through the twilight zone and into the pitch-black depths where no light from the surface can reach. Here, from 6,000 meters down to the very bottom of the trench, lies the Hadal Zone, the deepest part of the ocean, a realm so remote and mysterious that it has been compared to an alien world. The name Hadal is drawn from Hades, the underworld of Greek mythology, and it is a fitting description for such an extreme environment. Down here, the world is shrouded in perpetual darkness, and the landscape is sculpted by unimaginable forces. The pressure is so intense that it would crush a human submarine like a tin can. The water temperature hovers just above freezing, and the darkness is so complete that even the most sensitive eyes would see nothing but black. For centuries, scientists believed that life could not possibly survive under such crushing pressure and frigid cold. The seafloor was thought to be a barren wasteland, devoid of movement or sound, but as our technology advanced and we sent robotic explorers into the abyss, we discovered a world teeming with life. The Hadal Zone is home to a surprising variety of creatures, each with remarkable adaptations that allow it to thrive in a world that would be instantly lethal to almost any other organism on Earth. Among the most iconic residents of this deep world is the Mariana snailfish, This unassuming creature has become a symbol of survival against all odds. Picture a small, translucent fish, its body almost ghost-like, gliding effortlessly through the water at depths of around 8,000 meters. The Mariana snailfish holds the record for the deepest living fish ever found, thriving where the pressure is more than 1,000 times greater than at the surface. Its body appears fragile, almost as if it could dissolve at a touch, but this delicate appearance is its secret weapon. The snailfish's soft, gelatinous body is perfectly adapted to the crushing pressure of the deep. Unlike most fish, the Mariana snailfish lacks a swim bladder, the gas-filled sac that helps fish control their buoyancy. In the hadal zone, the immense pressure would collapse such a structure instantly. Instead, the snailfish relies on soft tissues and flexible cartilaginous bones. These adaptations allow it to withstand the weight of the water above, moving with a grace that belies the harshness of its environment. In this silent world, the snailfish is a master hunter, gliding over the seafloor in search of tiny crustaceans. Every movement is calculated, every flick of its tail a testament to millions of years of evolution. But the hadal zone is not just home to fish. Among the strangest inhabitants are the xenophyrophores, creatures so bizarre they seem to defy the rules of biology. At first glance, xenophyrophores look like sponges or corals, but they are actually giant single-celled organisms. Some can grow up to 20 centimeters across, making them among the largest single cells on Earth. These ultimate minimalists thrive as solitary giants on the sea floor, their entire existence contained within a single complex cell. Yet despite their simplicity, xenophyrophores play a crucial role in the deep-sea ecosystem. They are ecosystem engineers, shaping their environment in ways that benefit countless other species. By building intricate shells from sediment and their own waste, xenophyrophores create stable structures on the soft seabed, tiny fortresses in a shifting world. These structures become havens for other smaller organisms, providing shelter and microhabitats. In the vast emptiness of the trench floor, they are islands of life, supporting a hidden web of biodiversity. Life here is built differently. Every creature is a marvel of adaptation, shaped by the relentless pressure and darkness. Take the giant amphipods, for example. These relatives of the tiny shrimp you might find in a tide pool have grown to monstrous proportions in the trench, reaching up to 34 centimeters long, nearly the size of a dinner plate. This phenomenon, known as deep-sea gigantism, is a common theme in the abyss, though scientists are still unraveling its mysteries. Some believe it helps animals store more energy or survive in the cold, food-scarce environment. These giant crustaceans have evolved a unique defense against the crushing pressure. Their bodies contain high levels of aluminum, which they extract from the mud on the sea floor. The aluminum forms a gel-like armor within their bodies, creating a protective layer that shields their cells from being crushed by the immense weight of the water above. As armored scavengers, these amphipods roam the trench floor, feeding on any organic matter that drifts down from the world above. In this way, they help recycle nutrients, playing a vital role in the deep-sea ecosystem. The hadal zone, once thought to be lifeless, is now known as a place of astonishing resilience and adaptation, a testament to the power of life to endure even in the most extreme corners of our planet. As we begin our slow ascent from the very bottom of the Mariana Trench, the crushing silence is broken only by the faint hum of our submersible's lights and instruments. The world below us fades into darkness, and we rise through a realm that few eyes have ever seen. We pass along the steep, shadowy slopes of the trench, leaving behind the abyssal plain and entering the perpetual twilight zone, a place where sunlight never truly penetrates, and the boundary between night and day is forever blurred. Here, in this world of endless dusk, shadows stretch and twist, and the only illumination comes from the living light of the creatures themselves. It is a domain ruled by the strange and the extraordinary, where evolution has crafted some of the most bizarre and fascinating predators on Earth. In this eternal night, survival is a delicate dance. Every creature must master the arts of hunting, hiding and communicating in near-total darkness. The stakes are high, and every adaptation is a matter of life and death. Many of these denizens have evolved a remarkable power, the ability to create their own light. This phenomenon, known as bioluminescence, is both a beacon and a weapon in the deep. Some use it to lure unsuspecting prey into their waiting jaws, while others flash sudden bursts of light to startle would-be predators, buying precious seconds to escape. Still others use their glow to find mates, sending out silent signals in the endless night, hoping for a response in the vast emptiness. In this world, light is not a gift from the distant sun, but a tool forged by life itself, a currency of survival, communication, and deception. Among the most infamous hunters of these depths is the sea devil anglerfish, a creature whose very existence seems to defy the imagination. With a grotesquely oversized mouth bristling with needle-sharp teeth, the anglerfish is a living nightmare, perfectly adapted to the darkness. From its head juts a long, fleshy rod tipped with a glowing lure that pulses and flickers in the blackness like a ghostly lantern. This lure is home to a colony of bioluminescent bacteria, which the anglerfish cultivates and uses to attract the curious and the hungry, small fish and crustaceans drawn in by the promise of an easy meal. When an unsuspecting victim approaches, mesmerized by the strange dancing light, the anglerfish's massive jaws snap shut with lightning speed, trapping the prey in a cage of teeth. The anglerfish's story grows even stranger when we consider its reproductive strategy. The male is a tiny, almost insignificant fraction of the female's size, and his entire existence is devoted to finding a mate in the vast, empty darkness. When he finally locates a female, he latches onto her body, fusing with her skin and bloodstream, becoming a permanent parasite. In this desperate strategy, he ensures that in a world where encounters are rare, reproduction is always possible. But the anglerfish is not the only terror lurking in the deep. Another fearsome predator stalks these waters, the deep-sea dragonfish. The dragonfish is a slender, jet-black hunter, gliding silently through the darkness with a glowing barbel dangling from its chin, a living fishing rod swaying gently to attract prey. This lure pulses with light, drawing in smaller fish and invertebrates, who are oblivious to the danger that awaits. But the dragonfish possesses a secret weapon, one that sets it apart from nearly every other creature in the deep. While most deep-sea animals produce blue or green bioluminescent light, colors that travel farthest through water, the dragonfish can also generate a rare, eerie red light, invisible to almost all other inhabitants of the deep. Most deep-sea creatures have lost the ability to see red, as it is the first color to be filtered out by the ocean's depths, vanishing just a few meters below the surface. In these inky waters, red is the color of invisibility, but the dragonfish's eyes are specially adapted to see this hidden spectrum, giving it a unique advantage. It can shine a beam of red light onto its prey, illuminating them in a spotlight that only the dragonfish can see, rendering its victims visible while remaining invisible itself. This secret spotlight turns the dragonfish into a master of stealth and surprise, a true phantom of the deep. Yet the dragonfish is not alone in these ancient waters. Another resident, the frilled shark, glides through the darkness, a living relic from a forgotten age. Often called a living fossil, the frilled shark's lineage stretches back millions of years, unchanged by time, perfectly suited to its shadowy world. Its body is long and eel-like, and its mouth is a terrifying maw lined with 300 backward-facing teeth, arranged in multiple rows, each one designed to trap and hold slippery prey. The frilled shark is thought to be an ambush predator, lurking in the darkness, waiting for the perfect moment to strike. When prey comes close, it coils its body like a snake and lunges forward with astonishing speed, ensnaring its victim in a sudden, inescapable attack. Its flexible jaws can open wide, allowing it to swallow prey whole, no matter the size. Swimming alongside the frilled shark is another ancient marvel, the goblin shark, With its long, flattened snout covered in sensitive electroreceptors, the goblin shark can detect the faintest electrical signals given off by the muscles of its prey, even in total darkness. But its most startling adaptation is its jaw, which can shoot forward in a sudden burst, snatching fish and squid from the water with terrifying speed, a living trap sprung in the blink of an eye. In the vast, dark plains of the deep sea, food is incredibly scarce. The environment is harsh, with crushing pressures and near-freezing temperatures. Most of the life on the seafloor survives on a constant, slow drizzle of organic matter from the surface, known as marine snow. These tiny particles, consisting of dead plankton, fecal matter, and other organic debris, drift down from the sunlit layers above. It can take 1,000 years for enough of this material to accumulate to provide a substantial amount of energy. The seafloor becomes a patchwork of nutrient-rich sediments, a slow and steady accumulation that sustains the sparse life forms that dwell here. But very occasionally a truly enormous feast arrives from above. These events are rare, but when they occur, they transform the barren landscape into a bustling hub of activity. When a great whale dies in the open ocean, its massive carcass sinks, carrying with it a concentrated burst of nutrients. This descent is a dramatic journey, as the whale's body slowly drifts down through the water column, eventually coming to rest on the sea floor. This event, known as a whale fall, creates a temporary, bustling ecosystem in the barren abyss, an oasis of life that can last for a century. The whale's body becomes a rich source of food, attracting a diverse array of deep-sea creatures. The first to arrive at the feast are the mobile scavengers. These opportunistic feeders are drawn by the scent of the decaying flesh, which can travel for miles in the deep ocean. Within hours, the scent of the decaying carcass attracts hagfish, sleeper sharks, and giant amphipods from miles around. These creatures are adapted to detect and locate food in the vast, dark expanse of the deep sea. These creatures are voracious eaters, capable of consuming up to 60 kilograms of soft tissue every single day. They work quickly, stripping the whale's body of its flesh in a matter of months. They burrow into the whale's body, stripping it of its flesh in a feeding frenzy that can last for over a year. The once intact carcass is rapidly reduced to bones as the scavengers leave nothing but the skeleton behind. It is a gruesome but vital process, quickly recycling the whale's energy and distributing it into the deep-sea food web. The nutrients from the whale's body are spread throughout the ecosystem, supporting a wide range of life forms. The sheer number of scavengers that gather is a testament to how rare such a windfall is. These events are infrequent, and when they occur, they provide a significant boost to the deep-sea community. Once the soft tissues have been devoured, a new community of organisms takes over. These are the enrichment opportunist species, which thrive on the remaining nutrients in the whale's bones. This is the enrichment opportunist stage. The whale's skeleton, rich in oils and lipids, becomes the new focus for these organisms. The whale's skeleton, rich in oils and lipids, becomes the new focus. These nutrients are slowly released over time, providing a long-term food source for the deep-sea community. Among the most remarkable of these specialists are the worms, sometimes called zombie worms. These creatures have evolved unique adaptations to exploit the whale's bones. These creatures have no mouths or stomachs. Instead, they secrete a powerful acid that dissolves the bone, and they use root-like structures to absorb the lipids directly from the marrow. Instead, they secrete a powerful acid that dissolves the bone, and they use root-like structures to absorb the lipids directly from the marrow. This unique feeding strategy allows them to thrive in an environment where food is scarce. A single whale skeleton can support a thriving colony of these strange worms for several years, their brightly colored plumes covering the bones like a fuzzy carpet. The sight of these worms with their vibrant hues is a stark contrast to the dark, desolate surroundings. The final stage of the whale fall can last for decades, even up to a century. During this time, the whale's bones continue to provide a habitat for a variety of deep-sea organisms. As bacteria continue to break down the remaining lipids within the bones, they produce hydrogen sulfide, the chemical that gives rotten eggs their smell. This process releases energy that supports a new community of life. This chemical, toxic to most life, is a source of energy for a whole new community of organisms. These chemosynthetic bacteria convert the hydrogen sulfide into energy, forming the base of a unique food web. Mussels, clams, and worms that have a symbiotic relationship with chemosynthetic bacteria colonize the skeleton. These organisms rely on the bacteria to convert the hydrogen sulfide into usable energy. They use the hydrogen sulfide to create energy, forming a food web completely independent of sunlight. This unique ecosystem thrives in the dark, cold depths of the ocean, far removed from the sunlit world above. Eventually, all that remains is a clean skeleton, which then serves as a reef-like structure for filter feeders, a final monument to the great whale that gave its life to the deep. This skeletal reef provides a habitat for a variety of marine life, continuing to support the deep-sea ecosystem long after the whale's death. In certain parts of the Mariana Trench, the seafloor is not a cold, quiet place. Instead, it is a dynamic landscape of intense geological activity, where the Earth's crust is alive with movement and transformation. Here, the seafloor is a canvas of volcanic activity, with magma bubbling just beneath the surface, creating a dramatic and ever-changing environment. Cracks and fissures in the Earth's crust allow cold seawater to seep deep down, where it is heated by the molten rock below. This process transforms the water into a superheated mineral-rich solution. This superheated mineral-rich water then erupts back into the ocean through fissures known as hydrothermal vents, creating spectacular underwater geysers. These vents spew out black clouds of chemicals like hydrogen sulfide and methane, forming towering chimney-like structures on the seabed known as black smokers. The landscape around these vents looks like it belongs on another planet, with plumes of chemical smoke and shimmering heat, creating an otherworldly scene. For a long time, it was believed that all life on Earth ultimately depended on the sun for energy, with photosynthesis being the foundation of the food web. But the discovery of hydrothermal vents turned this idea on its head, revealing a new type of ecosystem that thrives in complete darkness. At the base of this unique food web are chemosynthetic microbes, which do not rely on sunlight, but instead harness the chemical energy from the minerals pouring out of the vents. These remarkable bacteria and archaea use the hydrogen sulfide and other chemicals from the vent fluid to produce organic matter, serving as the primary producers in this dark world. The chemical-rich water flowing from the vents provides the necessary ingredients for these microbes to thrive, creating dense colonies that form the foundation of the vent ecosystem. These microbes convert inorganic chemicals into organic matter, supporting a complex and vibrant community of life around the vents. Recent studies in 2025 have found over 1 billion of these bacterial cells in a single gram of sediment near the vents, forming a thick living mat on the sea floor. This abundance of microbial life supports a dense and fantastical community of larger animals, each uniquely adapted to this extreme environment. Among the most striking inhabitants are the giant tube worms, which can grow up to 2.5 meters tall. These creatures have white tubes topped with brilliant red plumes, creating a stunning contrast against the dark seafloor. Remarkably, they have no mouth, no gut, and no digestive system at all. Instead, they are packed with symbiotic bacteria that live inside their bodies. The red plume acts like a gill, absorbing chemicals from the vent fluid and oxygen from the seawater. It transports these chemicals to the bacteria living inside its body, which in turn convert them into sugars that feed the worm. This symbiotic relationship is a perfect partnership, a life built on chemistry rather than sunlight. Other creatures in this ecosystem have developed equally ingenious ways to thrive in the harsh conditions around the vents. The yeti crab, for example, is named for its hairy claws, which are covered in bristles. It cultivates gardens of chemosynthetic bacteria on these bristles, waving its claws in the mineral-rich vent fluid to help them grow. The crab then uses comb-like mouthparts to scrape off and eat the bacteria it has farmed, providing a significant portion of its energy needs. For some species of yeti crab, this self-grown food can provide up to 85% of their total energy needs, showcasing an incredible adaptation to their environment. These vent ecosystems show us that the rules for life are far more flexible than we ever imagined, and that even in the most hostile environments, life finds a way to flourish in spectacular fashion. Despite its isolation, the Mariana Trench, Earth's deepest and most mysterious chasm, has not remained untouched by the reach of humanity. For centuries it was imagined as a realm beyond our influence, a place so remote and inaccessible that it would remain forever pristine. But as explorers and scientists have ventured into its depths, a sobering truth has emerged. Even here, in the planet's most extreme environment, the mark of human activity is unmistakable. What was once thought to be the last untouched wilderness on Earth now bears the unmistakable signs of our presence. Human debris, plastic wrappers, metal fragments, and other remnants lie scattered across the ocean floor, carried here by forces both seen and unseen. The ocean's vast currents, swirling ceaselessly around the globe, act as a conveyor belt for our waste. These powerful flows gather pollutants from distant continents, sweeping them across thousands of miles and depositing them in the most unlikely places, including the trench's deepest recesses. Imagine a plastic bottle discarded on a city street, washed into a river, and carried out to sea. Over months or years it is broken down by sunlight and waves, fragmented into smaller and smaller pieces, until it is swept by currents into the abyss. There it joins a growing collection of debris accumulating in a place once thought unreachable. The discovery of this hidden pollution has been a wake-up call for scientists. In the silence of the deep, researchers have found evidence of our impact: samples tainted with chemicals, animals with foreign particles in their bodies, and a landscape forever altered by our actions. In laboratories around the world, scientists painstakingly analyze tissue samples from deep-sea creatures. To their astonishment, they have detected chemicals that were banned decades ago, substances that should have vanished from the environment, yet persist in the bodies of trench inhabitants. Persistent organic pollutants, or POPs, such as PCBs, were once widely used in industry and manufacturing. Factories released them into rivers and oceans, where they lingered long after their use was outlawed in the 1970s. These chemicals are notorious for their resilience. They do not break down easily, instead accumulating in the fatty tissues of animals, moving up the food chain and concentrating in the bodies of predators. When scientists compared amphipods from the trench to crabs from some of the world's most polluted rivers, they were stunned. The amphipods, tiny, shrimp-like creatures, contained even higher levels of these toxic chemicals, a testament to the trench's role as a final gathering place for the world's pollution. The trench acts as a vast, silent sink, drawing in pollutants from across the globe. These substances become embedded in the deep-sea food web, affecting creatures that have never seen the light of day. But perhaps the most pervasive sign of our presence is plastic. From shopping bags to fishing nets, plastic waste has found its way to the very bottom of the ocean. Microplastics, tiny fragments created as larger pieces break down, are now found in every sediment sample and every species collected from the trench. These particles are so small they can be ingested by even the tiniest organisms, entering the food web at its very base. In one study, over 72% of amphipods examined had plastic fibers in their digestive tracts. These creatures, living in perpetual darkness, are now unwitting carriers of our waste. The effects of these microplastics are still being studied. They can block digestive systems, leach harmful chemicals, and potentially disrupt entire ecosystems. Yet the full consequences for deep-sea life remain a mystery hidden in the darkness. Larger items too have been found: sunken trash, lost fishing gear, and even household objects, all resting on the ocean floor. Perhaps the most haunting image is that of a single plastic bag, filmed at the bottom of the Challenger Deep. It drifts gently in the current, a stark reminder of how far our disposable culture has reached, a piece of everyday life now lying in the planet's most inaccessible place. The trench also holds evidence of our atomic past. During the mid-20th century, nuclear bomb tests released radioactive carbon into the atmosphere, a signature that has now settled on the seafloor. Radioactive carbon-14, created in the fireballs of atomic explosions, has travelled through the atmosphere, dissolved into the ocean, and finally settled in the bodies of deep-sea organisms. Today, scientists can detect this radioactive marker in the tissues of creatures living miles beneath the surface, a permanent record of human history written in the biology of the deep. These discoveries reveal a profound truth: the surface and the deep are inextricably linked. Our actions, no matter how distant, can have consequences in the most remote corners of the planet. In response, a new wave of conservation efforts is beginning to take shape. Scientists, conservationists, and governments are working together to protect these fragile ecosystems before it is too late. In 2024, the United States took a significant step by strengthening protections for the Mariana Trench Marine National Monument. Scientists are now using cutting-edge technologies such as environmental DNA sampling to monitor the health of this unique ecosystem, gathering information without disturbing its delicate balance. Through these efforts, there is hope that the trench and the life it harbours can be preserved for generations to come. Despite the immense challenges and dangers that have long kept the Mariana Trench shrouded in mystery, we now stand at the threshold of a new era, a golden age of exploration that is transforming our understanding of the deepest parts of our planet. The journey to this point has been marked by decades of innovation, courage, and relentless curiosity. Each new expedition, equipped with ever more sophisticated technology, peels back another layer of the trench's secrets. These missions are not just about sending machines into the abyss, they are about extending the reach of human curiosity into a world that is far more complex, diverse, and dynamic than we ever dared to imagine. The introduction of remotely operated vehicles and autonomous robotics has revolutionized deep-sea science. Scientists can now spend hours, even days, on the seafloor, virtually gathering high-definition video, collecting pristine biological and geological samples, and observing life in its natural, undisturbed state. These robotic explorers are our eyes and hands in a realm where no human could survive unprotected. Back on the surface, teams of researchers pore over the samples and footage, uncovering new species, strange geological formations, and chemical processes that challenge our understanding of what is possible on Earth. These discoveries are rewriting the textbooks on deep-sea biology, geology, and the very limits of life itself. The age of discovery in the deep sea is not a relic of the past, it is alive and accelerating. With every new dive, we realize that the story of the Mariana Trench is only just beginning to unfold. Recent discoveries have been nothing short of astonishing, sparking excitement and wonder among scientists and the public alike. Each breakthrough is a reminder of how much remains unknown. In 2019, for example, researchers identified a completely new species of snailfish, a ghostly creature perfectly adapted to the crushing pressures and perpetual darkness of the Hadal zone. This discovery added to the growing family of fish that have managed to conquer the trench's extreme environment, revealing the astonishing adaptability of life. But the wonders do not end with what we can see. Using metagenomic analysis, a technique that sequences all the DNA present in a sample, Scientists have begun to unlock the invisible world of microbes living in the trench's sediments. This approach has revealed a staggering amount of microbial diversity, hinting at entire ecosystems thriving beneath the sea floor. In a groundbreaking study published in 2025, researchers identified over 7,500 previously unrecorded species of microbes from a single expedition to the trench floor. Each of these microscopic organisms plays a vital role in the ecosystem, driving chemical cycles and supporting the food web in ways we are only beginning to understand. These tiny, unseen life forms form the very foundation of the Hadal ecosystem. Their existence challenges our assumptions about where and how life can thrive, and they may even hold clues to the origins of life on Earth and the possibility of life elsewhere in the universe. New technologies are also giving us unprecedented insights into the behavior of deep-sea animals. For the first time, we can observe how these creatures hunt, communicate, and interact in their natural environment, far from the disruptive presence of humans. In 2024, a team of scientists finally unraveled the mystery of the barrel-eye fish, a bizarre animal with a transparent head and upward-gazing eyes. High-definition footage revealed how it uses its unique anatomy to maintain perfect buoyancy and ambush prey in the twilight zone, a feat of evolutionary engineering that had puzzled researchers for decades. Meanwhile, data recorders attached to Yeti crabs have confirmed a long-standing hypothesis. These remarkable animals really do farm bacteria on their claws, harvesting them as a primary food source. This symbiotic relationship is a testament to the ingenuity of life in the deep sea, where every survival strategy is pushed to its limits. These discoveries are not mere curiosities. They are vivid demonstrations of how evolution has forged unique solutions to the extreme challenges of deep-sea life, providing a masterclass in adaptation, resilience, and survival against all odds. Looking ahead, the future of trench exploration promises even more wonders. New generations of submersibles, equipped with artificial intelligence and advanced sensors, are being designed to reach greater depths, stay longer, and collect more data than ever before. Ambitious projects are underway to use seismic data and advanced mapping techniques to create the most detailed, three-dimensional maps of the Challenger deep structure ever attempted. These maps could reveal the forces that have shaped the trench over millions of years, and perhaps even explain why it is the deepest place on Earth. Plans are in motion to deploy long-term observatories on the trench floor, networks of sensors and cameras that will provide a continuous stream of data, monitoring everything from deep-sea earthquakes and chemical changes to the subtle shifts in animal populations. For the first time, we will be able to witness the trench as a living, changing environment. The Mariana Trench is more than just a deep scar in the ocean floor. It is a vast library of natural history, holding secrets about the evolution of life, the geology of our planet, and perhaps even clues to what life might look like on other worlds. Every sample, every observation is a page in a story that stretches back billions of years. It is a world of perpetual darkness, yet it is illuminating our understanding of the planet in countless ways. As we continue to explore, discover, and learn, the Mariana Trench reminds us that the greatest mysteries and the greatest adventures still lie beneath the surface, waiting to be revealed. Beneath the crushing weight of the Pacific Ocean, the Mariana Trench is not simply a chasm. It is a masterpiece of geological artistry, sculpted over millions of years by the relentless forces of the Earth. While much of our fascination with the trench centers on its extraordinary life forms, the very structure of the abyss tells a story just as captivating. Stretching nearly 11 kilometers deep, the trench is the result of a dramatic collision between two massive tectonic plates, the Pacific Plate and the smaller Mariana Plate. Here at the edge of the world, the Pacific Plate dives beneath its neighbor in a process called subduction. It is this slow-motion plunge that has carved the trench's signature crescent shape, forming the deepest known point on our planet, the Challenger Deep. But the trench is more than a simple crack in the sea floor. Its walls are layered with steep escarpments, towering cliffs, and chaotic rock formations shaped by landslides and earthquakes that rattle the abyss. Along the trench's flanks, immense slabs of ancient ocean crust have been bent, twisted, and fractured, creating a landscape as alien as any found on another planet. Bizarre features like serpentinite mud volcanoes rise from the depths, releasing mineral-rich fluids that alter the chemistry of the water and feed unique microbial communities. Recent advances in sonar mapping have revealed a hidden world of canyons, terraces, and isolated seamounts, underwater mountains that rise thousands of meters from the trench floor. These formations create a patchwork of habitats, each with its own distinct environment and challenges for life. In some places, the pressure is so intense that rocks themselves flow and deform, while elsewhere, deep fissures vent superheated fluids, fueling a complex web of geological and biological interactions. Every layer of sediment, every jagged ridge is a record of ancient earthquakes, submarine landslides, and the slow, inexorable dance of continents. Scientists studying the trench's geology are uncovering clues to the history of our planet. Evidence of past tsunamis, the formation of new minerals under extreme conditions, and even the recycling of Earth's crust into the mantle below. In the silent darkness of the Mariana Trench, the rocks themselves are storytellers. They whisper of violent upheavals, relentless erosion, and the unyielding power of plate tectonics. As we continue to explore this hidden world, we are reminded that the greatest depths of the ocean are not only home to extraordinary life, but also to some of the most remarkable geological wonders on Earth. Far below the sunlit waves, in a realm where darkness reigns and pressure mounts to over 1,000 times what we feel at sea level, life not only endures, it thrives in ways that defy imagination. The Mariana Trench, a place seemingly inhospitable to life, is in fact home to some of the most extraordinary and resilient creatures ever discovered. Here, the rules of biology are rewritten. The water is near freezing, and the absence of sunlight means no plants can grow. Yet, scattered across the trench's alien landscape, life has carved out a niche in every possible corner. At the deepest points, ghostly amphipods, tiny shrimp-like scavengers, drift through the water, their transparent bodies adapted to withstand immense pressure. Scientists have even discovered species like the Mariana snailfish, a delicate yet astonishingly tough creature that holds the record for living deeper than any other fish on the planet. Its body is soft and gelatinous, allowing it to survive where bones would shatter. Other residents are even stranger. Giant, single-celled organisms called xenophoephores sprawl across the muddy seafloor, growing to the size of dinner plates and filtering nutrients from the sediment. Nearby, mysterious cusk eels and bizarre-looking holothurians, or sea cucumbers, glide silently over the abyssal plain, each perfectly adapted to the perpetual night. But the real marvel lies in how these creatures survive. Many feed on a constant rain of organic debris known as marine snow that drifts down from the world above. Others cluster around hydrothermal vents and cold seeps where they rely on chemosynthetic bacteria, organisms that turn chemicals into energy in the absence of sunlight. These bacteria form the foundation of a unique food web, supporting tube worms, clams, and other vent dwellers found nowhere else on Earth. Every new expedition uncovers life forms that challenge our understanding of biology, organisms with enzymes that function at crushing pressures, and cell membranes that remain fluid in the coldest, darkest waters. Some may hold clues to the origins of life itself, or even provide insights into the possibility of life on other worlds. In the silent, pitch-black depths of the Mariana Trench, life has not only survived, it has flourished, evolving into shapes and strategies as strange and wondrous as the abyss itself. The more we learn about these remarkable inhabitants, the more we realize the final frontier on Earth is not barren but bursting with secrets, waiting to be discovered. In the uncharted depths of the Mariana Trench, human curiosity knows no bounds. The quest to explore this enigmatic abyss has driven scientists and explorers to push the limits of technology and endurance. This is a journey that begins with a single question: what lies beneath? The first daring exploration occurred in 1960 when the bathyscaphe Trieste, piloted by Jacques Piccard and Don Walsh, descended into the Challenger Deep, the trench's deepest part. Despite the rudimentary technology of the time, they reached a depth of nearly 11,000 meters, shattering previous records and opening a window into a world few believed was possible to reach. Decades later, in 2012, filmmaker and explorer James Cameron reignited the flame of deep-sea exploration with his solo dive in the Deep-Sea Challenger. Equipped with advanced cameras and scientific instruments, Cameron captured high-definition footage of the trench's alien landscape, providing invaluable data and vivid imagery that mesmerized the world. These monumental dives were just the beginning. Modern expeditions utilize remotely operated vehicles, ROVs, and autonomous underwater vehicles, AUVs, bristling with cutting-edge technology. These robotic explorers are capable of withstanding the crushing pressures and freezing temperatures of the trench, sending back data in real time. The ROVs are equipped with high-definition cameras, robotic arms, and a suite of sensors that can analyze water chemistry, temperature, and pressure, as well as collect biological and geological samples. One such ROV, named Deep Discoverer, has been instrumental in uncovering the trench's secrets. Operated by NOAA's Office of Ocean Exploration and Research, Deep Discoverer has mapped vast sections of the trench, revealing its rugged terrain, including towering seamounts and deep foreboding canyons. The data collected has provided scientists with a better understanding of the trench's geological activity, including the tectonic movements that shape its dramatic features. But the quest for knowledge doesn't end with mapping. Scientists are also focused on understanding the unique ecosystems that thrive in these extreme conditions. By studying the trench's inhabitants, researchers hope to unlock the mysteries of life's adaptability and resilience. These insights could have far-reaching implications, from developing new medical therapies to understanding how life might exist on other planets. In recent years, international collaborations have expanded our knowledge even further. Countries around the world have joined forces, sharing their resources and expertise to explore the trench more comprehensively. These collaborative efforts have led to groundbreaking discoveries, such as the identification of new species and the uncovering of previously unknown hydrothermal vent systems. As we continue to explore the Mariana Trench, we are reminded of the boundless potential of human ingenuity and the enduring spirit of discovery. The trench stands as a testament to our relentless pursuit of knowledge, a final frontier that challenges us to look beyond the surface and delve into the depths of the unknown. In this silent, pitch-black realm, every new discovery is a testament to our unyielding curiosity and the endless possibilities that await us beneath the waves. The Mariana Trench, with all its mysteries, remains a beacon for explorers, scientists, and dreamers alike, a place where the quest into the unknown continues to inspire and amaze. Beneath the crushing darkness of the Mariana Trench, human ambition has summoned technology unlike anything the world has ever seen. The story of deep-sea exploration is not just one of daring adventurers, but of relentless innovation, where each new discovery is powered by the tools we invent to push further into the unknown. In the early days, explorers relied on thick steel hulls and simple gauges, braving the abyss with little more than courage and a handful of analog dials. But as curiosity grew, so did the need for more sophisticated equipment. Enter the age of remotely operated vehicles, or ROVs, mechanical pioneers designed to plunge where no human dare venture. These robotic explorers are marvels of engineering, bristling with high-definition cameras, articulated arms and sensors that monitor every detail of the trench environment. Modern ROVs like the Deep Discoverer and Victor 6000 can descend to the trench floor, withstand immense pressures and relay live video feeds back to scientists on the surface. Their manipulator arms collect samples of rock, sediment, and even elusive life forms, turning the Mariana Trench into a living laboratory. But the technological revolution doesn't stop there. Autonomous underwater vehicles, or AUVs, operate without tethers, gliding through the blackness on pre-programmed missions. These sleek torpedo-shaped probes map the trench in stunning detail, using sonar and laser scanners to reveal hidden features and chart new territories. Advancements in pressure-resistant materials, energy-efficient batteries, and real-time data transmission have transformed our ability to explore. Today, deep-sea drones can operate for days at a time, traversing kilometers of rugged terrain while collecting terabytes of data. Their onboard computers analyze chemical signatures in the water, detect hydrothermal vents, and even listen for the faintest sounds of life. Collaboration between scientists, engineers, and private industry has fueled a golden era of exploration. International teams share technology and expertise, building a fleet of specialized submersibles and robotic explorers. Each mission brings new upgrades, more powerful thrusters, smarter navigation systems, and ultra-sensitive sensors that can detect life at the molecular level. With each leap forward, the Mariana Trench reveals more of its secrets. Technology has become our eyes, hands, and curiosity in the deep, pushing the boundaries of what we know and what we can only imagine. The future of deep-sea exploration is bright, illuminated not by sunlight, but by the spark of human ingenuity and the relentless march of technology, lighting our path even in the world's darkest abyss. Yet, as our technology pierces the darkness of the Mariana Trench, a new responsibility emerges, one that asks us not just to explore, but to protect. The trench is not only a frontier of discovery, but a sanctuary for life forms found nowhere else on Earth, and a vital piece of the planet's ecological puzzle. But even here, nearly 7 miles below the surface, the human footprint is unmistakable. Deep-diving submersibles have brought back samples of plastic debris, chemical pollutants, and even microplastics embedded in the tissues of trench-dwelling creatures. Scientific studies reveal that our actions on the surface ripple down into the deepest abyss, threatening fragile ecosystems that have survived unchanged for millennia. The Mariana Trench is a paradox, both remote and vulnerable. Its depths are home to species uniquely adapted to crushing pressures and eternal darkness, yet they are defenseless against toxins and waste that drift down from above. For conservationists and scientists alike, the message is clear. The time to act is now. International efforts are underway to safeguard this hidden world. In 2016, the United States designated the Marianas Trench Marine National Monument, protecting vast swathes of the trench from commercial exploitation. This legal shield bans mining, restricts fishing, and provides a framework for ongoing scientific research. But protection goes beyond laws and boundaries. Scientists collaborate with governments, NGOs, and local communities to monitor the trench's health, using advanced sensors and satellite data to track pollution and illegal activities. New protocols guide research missions, ensuring that every sample is collected with care and every dive leaves as little trace as possible. Education and advocacy are also key. Documentaries, museum exhibits, and public outreach campaigns bring the wonders and vulnerabilities of the Mariana Trench to the world's attention. The hope is to inspire a sense of stewardship, so that the urge to explore is matched by a commitment to preserve. The story of the Mariana Trench is still being written. As we venture further into its depths, we face a choice to leave behind scars or to become guardians of the deep. With wisdom, innovation, and compassion, we can ensure that the world's last great frontier remains not just a place of mystery, but a haven for life, untouched, unspoiled, and protected for generations to come. Long before sonar pings echoed through its depths, the Mariana Trench ignited imaginations as a place of wonder, terror, and mystery. For centuries, it has been the subject of legends whispered by sailors, islanders, and storytellers, each seeking to explain the secrets hidden beneath the waves. Some Pacific Islanders tell tales of ancestral spirits dwelling in the trench, guardians who watch over the ocean's deepest heart. In their stories, the trench is not just a chasm, but a sacred passage to another realm, a place where the souls of the departed journey to reunite with the sea. To early explorers, the trench was a world of monsters. Ancient mariners spun yarns of colossal sea serpents whose undulating shadows haunted the ocean's surface during storms. Fishermen spoke of the trembling waters, a patch of sea above the trench where ships vanished without a trace, swallowed by unseen forces lurking far below. Modern myths persist, fueled by our fascination with the unknown. Some wonder if the trench holds the remnants of lost civilizations, or even portals to other worlds. The eerie silence and crushing darkness feed the imagination. What if creatures exist here that defy science, hidden from human eyes for eons? Even today, each new discovery, from ghostly amphipods to shimmering jellyfish, rekindles the sense of awe that inspired these ancient legends. Scientists charting the trench encounter mysteries that sometimes echo old stories, strange sounds, unexplained movements, and life forms that seem almost otherworldly. The Mariana Trench remains a place where myth and reality blur. Its depths remind us that Earth still harbors secrets beyond our knowledge, and that the oldest stories of monsters, spirits, and hidden worlds are born from our enduring desire to understand the unknown. As we continue to explore, perhaps the greatest legend of all is this, that the abyss will always keep some of its mysteries, inviting us to dream, wonder, and imagine what lies beneath. As we stand at the threshold of the unknown, the Mariana Trench beckons not just as a relic of ancient legends, but as the next great frontier for human discovery. The future of deep-sea research promises to unveil secrets that, until now, have been locked away in darkness and silence for millions of years. Imagine fleets of autonomous submersibles powered by AI gliding silently through the trench's inky corridors. These machines, equipped with ultra-sensitive sensors and robotic arms, will reach places no human has ever seen, mapping every crevice and cataloguing life forms that defy our understanding of biology. Scientists envision sending swarms of microscopic robots capable of withstanding unimaginable pressure to study the trench at a scale finer than a grain of sand, unlocking clues to the origins of life itself. In the coming decades, international collaborations will transform the Mariana Trench into a living laboratory. Nations and institutions will share data in real time, creating a global network of oceanographers, biologists, and engineers. These partnerships may lead to breakthroughs in medicine, as unique enzymes and compounds from trench organisms inspire new treatments for disease. The study of extremophiles, organisms thriving in the trench's harshest environments, could even inform future missions to icy moons like Europa or Enceladus, guiding our search for life beyond Earth. But with new technology comes new responsibility. The future of deep-sea research will demand a careful balance between exploration and preservation. As we probe deeper, the voices of conservationists grow louder, reminding us that the trench is not just a scientific treasure, but a fragile ecosystem in need of protection. The Mariana Trench stands as a symbol of what lies ahead, a place where science, innovation, and imagination converge. Its depths whisper promises of discoveries that could reshape our understanding of the planet and ourselves. As we look to the future, one thing is certain: the journey into the abyss has only just begun. Beneath the waves, where boundaries dissolve and the darkness is absolute, the Mariana Trench quietly unites the world. In this remote undersea abyss, the spirit of discovery transcends borders, languages, and politics. Scientists from every corner of the globe converge, drawn together by a singular quest to unlock the secrets of Earth's deepest point. Picture a control room aglow with screens, Voices from Tokyo, Paris, Sydney and San Francisco interlace in real time, analyzing fresh data streaming up from the abyss. Japanese submersibles, American deep-sea robots and European sensor arrays all work in harmony, each a piece of a global puzzle. It's in these collaborations that oceanography finds its greatest strength, where the exchange of knowledge, technology and dreams accelerates discovery. Joint expeditions, like those led by the International Ocean Discovery Program, have mapped the trench's contours with unprecedented clarity. Teams have shared not only their findings, but the very vessels and instruments needed to probe the crushing depths. When a fragile biological sample ascends from the trench, it may pass through laboratories on 3 continents, each contributing unique expertise to unravel its mysteries. These partnerships have led to breakthroughs impossible in isolation. New species identified, ancient sediments dated, and methane seeps mapped. They have also fostered a culture of stewardship. Together, nations draft guidelines to protect the trench from pollution and overexploitation, ensuring that exploration does not come at the cost of preservation. The Mariana Trench reminds us that the ocean is a shared heritage, a realm where unity is not just an ideal, but a necessity. As we peer into the abyss, our greatest discoveries emerge not just from the depths, but from the ties that bind us above the waves. United by curiosity, respect, and wonder, humanity continues its greatest voyage, exploring the unknown together. The Mariana Trench is not just a frontier of discovery, it is a crucible of adversity. For every breakthrough, researchers face a gauntlet of challenges that test the limits of human ingenuity and endurance. Imagine the descent, a journey into utter blackness where sunlight has never reached, and the pressure is 1,000 times greater than at the surface. Here, even the most advanced technology is pushed to its breaking point. Deep-sea submersibles must withstand crushing forces that would flatten a steel locomotive. Every bolt, every circuit, every seal is meticulously engineered, but even then unexpected failures can strike. Sometimes a robotic arm locks up in the cold, or a camera lens shatters under pressure, leaving researchers to improvise solutions miles below the waves. The human element is just as vulnerable. Teams endure grueling schedules aboard research vessels where isolation and rough seas are constant companions. Communication with the outside world is limited. Days and nights blur together under artificial light. Fatigue, seasickness, and the ever-present hum of machinery become the soundtrack of discovery. But perhaps the greatest challenge is the unknown itself. The trench is a place of surprises, unexpected currents, shifting sediments, and elusive life forms that defy easy capture or observation. Each dive is a leap into mystery, where careful planning meets the unpredictable reality of the abyss. Despite these hardships, researchers return again and again, driven by curiosity and the hope of illuminating the darkest corners of our planet. Their perseverance writes a story of resilience, one where every setback is met with determination, and every hardship brings us closer to understanding the profound secrets hidden in the depths. In the Mariana Trench, the true measure of discovery is not just what we find, but what we overcome to reach it. In the last decade, the Mariana Trench has transformed from a shadowy unknown into a stage for some of science's most astonishing discoveries. As technology has leapt forward, so too has our ability to peel back the veil of darkness that once shrouded the trench's secrets. One of the most remarkable breakthroughs came in 2016, when scientists captured high-definition footage of a ghostly, translucent snailfish gliding effortlessly at a depth deeper than any fish had been seen before. Its delicate body, adapted to withstand crushing pressures, challenged everything we thought we knew about the limits of vertebrate life. But the surprises didn't stop there. In 2019, explorers deployed autonomous landers equipped with cutting-edge sensors and samplers, revealing entire communities of strange organisms clustered around fissures in the seafloor. These creatures, many never seen before, thrive in total darkness, drawing energy not from the sun, but from chemical reactions deep within the Earth. Researchers have also uncovered clues to the trench's role in the global carbon cycle. By sampling sediments nearly 11 kilometers down, they found evidence that the Mariana Trench acts as a vast carbon sink, trapping organic material that sinks from the upper ocean. This discovery has profound implications for our understanding of how the deep sea helps regulate Earth's climate. Even human-made artifacts have turned up in these remote depths, including a plastic bag and candy wrappers, sobering reminders of our planet's interconnectedness and the reach of our impact. Each expedition brings new data, new mysteries, and new hope. From bizarre life forms to vital geochemical processes, the recent discoveries in the Mariana Trench remind us that our planet's greatest wonders and challenges still lie far beneath the waves. And with every dive, we come a little closer to unraveling the story of the world's deepest frontier.